Okay, so this week we're in the parent class. We're covering the end of chapter 3, our chapter on symbolic logic. And the entire chapter we've been working with these things called truth tables. It's a major part of what we're doing with symbolic logic. And here at the end of chapter 3 in the parent class, we're using truth tables to deal with arguments, to deal with formal arguments. So even though we've done a lot with these truth tables, I figured it would be a good idea this week in our support class just to practice them more and continue kind of getting more examples under our belts, just so you have a better handle on it. So I'm only going to do 2 examples here, and then the assignment this week is just going to be more like this. This first example here is only going to have 2 component statements, a P and a Q. This third example is going to have 3, P, Q, and R. And as you know, whenever we have more component statements, we end up with more rows in our truth table. So I'm going to start with this one. This one is not P or Q implies P and not Q. So what I'm going to do is create my columns here, starting with P and Q. And then I noticed that I have both a not P and a not Q showing up somewhere in this statement. So I'm going to want to have those included in their own columns. And then I have a not P or Q appearing in one set of parentheses here. So not P or Q. That gets its own column. I also have a P and not Q. P and, whoop, I was almost about to spell the word and there. Not Q. That gets its own column. And then finally, the entire statement is this implies this. So not P or Q implies P and not Q. And that large one there is its own column. So again, we always start this the same way. I have 2 component statements this time. I'm going to give them all combinations of truth values. And we kind of use the same format every time. True, 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 false, false, true, false, false. My negation columns will give me the opposite truth value of their partners over here. So my not P is going to look like false, false, true, true. The opposite of what we saw there. My not Q column is going to look like false, true, false, true. All right. Now this is a disjunction. So all I need is at least one of these component statements to be true. Either not P has to be true or Q has to be true, and they could both also be true. So my not P column is here, my Q column is here. I have a true in one of those columns, so this becomes true. Here in my second row, neither column contains a true, so that would be false. Here, both columns contain a true, so my disjunction is true. And here I have at least one true appearing in this column, so that's going to be a true as well. Over here we have P and not Q. Here's my P column, here's my Q column, or not Q column. So in this case, it's a conjunction, so we need both of them to be true in order for this statement to be true. In this case, I have a false here, so they are not both true. That becomes false. Here, both columns are showing a true, so I have true. Here, both columns are showing a false, and so I have false. Here, one of my columns has a false, so this is false. Okay, and finally, my last column here, we have this implies this. That's what's being stated right here. So I have a true implies false. We know from the conditional, that's false. We also, remember, anytime we have a conditional statement in which my antecedent is false, the conditional itself is automatically true. So the false in this column means that that conditional is true. I have true implies false, so that is false. And then I have another true implies false, so that is false. Okay? We almost have a contradiction here. Remember, if you have all falses in one column, or in your final column here, that's a contradiction. Because in no possible combination of truth values for P and Q can this statement ever be true. However, it's not quite a contradiction because we do have one row showing as true. Okay? So So move on to our next example. Remember, this one will have 8 rows instead of 4 rows like the previous example. So I'm going to need to make sure I have room for this. P, Q, and R are my basic component statements. Next, I look for any negations that appear. I have a not P and a not R, so I need columns for those. I don't have a not Q showing up anywhere, so I don't need to make a not Q column. Okay, now let's see what else we have. We have a P or Q appearing right there, P or Q. And then that disjunction is the antecedent in this conditional. P or Q implies R, so I'm then going to construct that. P or Q implies R. Also, I have a conjunction showing up here, not P and not R. And then finally, I have this column implies this column as that big conditional making up the entire statement. So that is going to look like this. P or Q implies R, implies not P and not R. Okay, so we're going to go like this. Now here, we're going to use, we're going to deal with these 3 columns, and I'm going to start with true, true, true. And then I'm going to say true, true, false. And then I'll say true, false, true, and then false, true, true. So again, my approach here is my first row, all 3 statements are true. Then I want to deal with all possible combinations of truth values where only one of my statements is false. So if only R is false, then the other 2 are true. If only Q is false, then these 2 are true. And if only P is false, then these 2 are true. Next, I want to deal with all possible combinations where only one of my statements is true and the other 2 are false. So that would be true, false, 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 true, false, and false, false, true. Finally, we look at the case where all 3 of them are false. Make my columns just a tad longer. Okay, here's my not P column. So I have 3 trues there, which will give me 3 falses here. And then I have false true, which will give me true false. And then I have 3 falses, that's 3 trues here. My not R column looks like true, false, true, true. That's going to become false, true, false, false. 2 falses gives me 2 trues. True, false gives me a false, true. So those are my negation columns now. Next up, I want to look at P or Q, this disjunction here. And again, only one of these component statements needs to be true in order for the disjunction to be true. So I'm looking at my first 3 columns here. I see that, or my first 3 rows, P is true in all of those cases. So I'm going to have 3 trues here. Next up, I have a true in this column and another true in this column. So those will be true. And then I have a true here as well. So that's going to be true. And my last 2 rows, both columns are showing up as false. So those are going to be false. Okay. Now we have P or Q implies R. So this column implies this column. This is the antecedent and this is the consequent. True implies true, true. True implies false, false. True implies true, true. Another pair of trues here is going to give me a true. True implies false. We know that to be false. True implies false, same thing as before. False and false in these last 2 cases. Remember, if the antecedent is false, then it doesn't matter what the consequent is. The conditional automatically becomes true. So that finishes that column. We're almost there. Now I have not P and not R. So that's these 2 columns right here. Remember, both of these need to be true in order for this to be true. Otherwise, they are false. So looking here, I have in my first, second, third, fourth, and 5th rows, all 5 of those rows have at least 1 false showing up. So that's going to be 5 falses in a row. Here I have a pair of trues. That's true. There's a false here, so that's going to give me false here, and then a pair of trues here. That gives me true there. Finally, I have this last conditional. So the column here is my antecedent, that column is my consequent, and so true implies false, false. False implies false, true. True implies false is false. True implies false, false again. I have a couple of falses here, which we know is automatically a true. True implies false would give me false, and then true implies true gives me true. Okay, I went through those fairly quickly, but that's just because we've had a lot of experience with these already, and it's just kind of getting some more exposure to them. So that's going to wrap it up for this week.